Okay guys, in this video we're going to learn on several techniques that we can use in conducting integration. Okay, these techniques will be useful when we encounter with a function that is rather complex. So there are going to be two kind of integration that you're going to learn. Basically three. So we have by integration by substitution. In some books the name is U substitution, and we also have integration by parts, and then we are going to also see how to conduct partial fraction. Okay, let us first look at integration by substitution. Okay, now there are several steps that you need to follow. However, this is not that crucial. You can do it based on your understanding. Okay, the other name of this kind of integration is called U substitution, because you will need to first define U. Okay, so let's say you have two functions inside one integration. So to integrate it, right, using integration by substitution, you are going to need to make a choice for U. For example, you have this one, x times root x squared plus 1. So you'll need to decide which will be your U. Okay, so then after you have determined the U, we are going to differentiate that U. So we do that so because we later will need to use the dx. Okay, so we differentiate du dx. Okay, and in the third step here is a step where you substitute dx with the terms du. Basically, in step 3, no x term should be remaining. So now you have x and x. After you conducting integration by substitution, where you substitute u, in the third step by right, there should be no x terms remaining. All of them should be in terms of u, including this. If it wasn't working, you are going to need to go back and choose a different u. And after we have successfully changed all of the terms that we have, x term that we have in this function into u, we can proceed with the integration. Okay, and after that we are going to replace the u that we have determined before into x. So we are going to change back our function that have been changed to u terms before into back to x terms. All right, well, let's try to do it, to see how it is done. And we look at exercise 4.13. First, we are going to let's do this one. Okay, this exercise. So first we are going to determine the u. X over x squared plus 4. What will be our u? Usually, alright, just a bit of hint. Usually, we are going to start with a function that is looking quite complex, right? So if we are comparing this and this, right, we can try to use this as our u. Okay, and then after we have this, then automatically our function change. Because we have already defined this as u, so this is how our function will look like. And of course, I rather put this on the numerator to make things easy later. Okay, now if you realize, we have u in here. Okay, so the next step is to differentiate this, right? After that comes step 3, where we need to change everything into u. Now we have x and x. We'll need to change everything into u. So we have this du over dx equal to 2x. So for this one, we have du. So the idea here is to substitute x dx to terms u. So how can we do that? So we're just going to move left and right hand side. So we can have x dx equal to du over 2. In other words, we can change this x dx, substitute it with du over 2. Now we can substitute it in our formula to remove x. As you can see now, instead of x, u negative 3 times dx, now we have everything in u terms. And of course, now we have a constant here. Just move it out to make things simple later in integrating this function. So the next thing to do is just to integrate this function. So negative 3 plus 1, you will get negative 2. So over the power negative 2. Right, negative 2, negative 2. We have moved the constant outside, and then we multiply to get this. This is the function after integration. And after we have successfully integrate the function, the last thing to do is to substitute back u. Our u just now is before is u equal to x, 2 plus 4, which is also equal to this function. So this is the answer for this question. Now let's look at the next one. Yeah, we are going to also see that substitution in integration is not just a one times work. Sometimes you will encounter with a function that require you to go back and change the u. Okay, so for this one, x times sine x squared. Right, by looking at it, we know that this is rather complex, right? So we can try to make u equal to sine x squared. We can try to do that. Okay. Then when you rewrite it back, this is what it will become. Then we can proceed with the differentiation, and when reaching this point, the next thing to do is actually step 3, where we need to make sure that we're able to remove the x and change it into u. So can we do that here? Okay, so this is the best that we can do to substitute x dx here. And spoiler alert, you'll see that we still have x in our terms, so we can't really use sine x squared as our u. So let's change it back. Now let's take the function inside this bracket as our u. So we have x sine u dx differentiate it, and we'll get this. So let's try to eliminate x dx. Alright, so x dx can be substituted into du over 2. Right, let's try to substitute it in our formula, in our function. And there you have it. There is no x there. So we can proceed with the next step, which is integrate the function. So we move out the constant and we just integrate sine u. Sine u will be equal to, when you integrate it, negative cos. So just multiply it in and you get, and substitute back u, don't forget that, x squared. So this will be the integration of this equation. Right? So that is how you conduct integration by substitution. In selecting u, there's also some that saying that you can substitute u based on the priority in conducting mathematical operation. For example, you should look at a function that is within bracket first. Right? That is, we also have that kind of school of thought. Right? But it is actually okay to try and error in finding u. Okay, so that is on integration by substitution. Thank you.